This is the first part of 3.6. We're going to solve what are called compound inequalities. Now, you had absolute value equations in chapter 2, and so what happens now is when you have absolute values in inequalities, you call them compound inequalities. And there's going to be 2 days on this, so here's the first part of that. So, you do have some vocabulary here. I do actually want you to write down the second one. We're going to do the last one in a different video. So in other words, what I'd like for you to do is copy down. In this section, in this video, what we're going to do is we're going to focus on intersections, which are the and compound inequalities. Okay. Basically, a compound inequality is when you put two inequalities together. So just get this one vocabulary word down. Go ahead and pause the video. Alright, now that you have the vocab down, basically with intersections, we're looking for the overlapping region of two number lines. That's where the solutions will be. So, what does this mean? Basically, with an and compound inequality, both parts must be true. Okay, both parts are the solution. So a number must work in both situations. If a number doesn't work in either of them, then it's considered no solutions. Those are like your special cases. So, what does an intersection look like? An and compound inequality basically takes two conditions and brings them together. Okay? So, if you look at it here, this is what we would call a Venn diagram. Okay? So, in group A, that's this circle right here, it says x must be less than 10. So they give us a few examples of numbers that are less than 10. 1, 2, 7, 9, negative 17, negative 4, negative 1. If we were to look at that graph, this is what it looks like. It would be an open circle on 10, and it would go to the left. So that's the first condition. The second condition says, it's in group B, x must be greater than 0. So here are numbers greater than 0 that are in the circle B. So we have 12, 15, 25, 1, 2, 7, and 9 in circle B. Here is the graph for the condition B, or circle B. Open circle on 0 to the right. Now, the compound part comes right here. Remember, in a Venn diagram, this section right here represents the items that they have in common together. That works for both. In this case, we have 1, 2, 7, and 9. So if you were to take group A's graph and overlap it with group B's graph, notice this piece is exactly the same. And notice if you look at this graph, there's no continuation. It says all the numbers between 0 and 10 will work. Let's try it. Let's try 4. Is 4 less than 10? Yes. Is 4 greater than 0? Yes. What about 6? 6 is less than 10 but greater than 0. What about 5? 5 is less than 10, greater than 0. So this represents everything that works for both conditions. Now, the tricky part is look at how the answer is written. With an and inequality, compound inequality, you always use less thans. Always, 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 always. Now, notice your variables in the middle. The leftmost number is your lower bound, or the lowest it can go. In this case, it's 0. And see how it's an open circle? That means this less than does not have an equal sign. The number all the way to the right represents the highest x can go. In this case, it is 10. It's also an open circle, so there's no equal sign there. Sometimes you will have open and closed circles here, the endpoints, okay? So, this is how you write your answer. This is how you do your graph. Okay? So, let's actually go ahead and do 2. So here are the first 2. And then we'll have 2 practice. Now, don't let these confuse you. Just because we have two inequalities doesn't mean it's going to be harder. X is in the middle. Now, let's say this wasn't there. How would you solve that? You would just minus 2 to the other side, right? Well, let's say the 4 part wasn't there. How would you solve that? You would still minus 2 to the other side. So what's really neat about this is we can do it to both sides at the same time. Always move what's on the inside out. So now I have 4 less than or equal to x less than or equal to 6. Now that x is isolated, I am done. This is a compound inequality. Okay? So, I'm going to do my graph. Now, since this is an and the reason I know it's an and is because x is in the middle. We're going to do ors tomorrow or in the next video, and your answer does not get written like this. So this is an and compound inequality. So put 4 at one end, 6 at the other. In this case, on the 4 it's a closed circle, on the 6 it's a closed circle, and it's everything in the middle. Okay, so there's your answer, there's your graph. Let's do the next one. So here we go. So again, when you do these, ask yourself, what would you do first here? We would minus the 3. What if it was the other way around? What would you do first here? You would still minus the 3. So we're going to minus 3 on all 3 sides. So I get 0 here, 6, negative 8. I now have negative 8 less than or equal to 2x less than 6. At this point now I need to divide by 2 on all 3 sides. Now be very careful here. I'm dividing by a positive number, so I do not have to flip these. If I had to divide by a negative 2 here, this inequality and this inequality would reverse their order. So now I get negative 4 less than or equal to x less than 3. I know I'm done because x is now isolated. And now I'm going to do my graph. So this is an and because x is in the middle. My lower bound, or my lowest it can go, is negative 4. My upper bound, or the highest it can go, is 3. At negative 4, I have a closed circle. At positive 3, I have an open circle, and it's everything in the middle. Okay? So, these are both and compound inequalities. So, go ahead and pause the video here. You have both of them to do. Alright, now that you've had a chance to try it, let's see how you did. In this problem here, what I'm going to do is I'm going to add 10. So now I have 1 less than x less than 5. I am now done. So now I'm going to do my graph. 1 is my lower bound, 5 is my upper bound, and it looks like I have open circles on both. Next one over here. I'm going to move the 5. Rewrite. Now this time I have to divide by 3. I'm dividing by a positive number, so I do not have to flip my inequalities. In my graph, I'll put it up here. My lower bound is -3, my upper bound is 2. I have a closed circle on -3 and an open circle on +2. So there you go. Hopefully you got both of those right. If you didn't, try and figure out what your mistake was. These are and compound inequalities. When we move on to absolute value inequalities, we're going to use this idea of ands and ors. So you need to know how to do these, so then in 3.7 we can add the next element. So that's it for today.